In the most distant regions of the observable universe, there are objects that appeared so early that their very existence seems to be a violation of the usual order of the cosmos. Their light began its journey when space was just emerging from the ancient age of darkness. The first generations of stars were just beginning to fill the young universe with energy, and galaxies were supposed to be small, chaotic, and relatively poor in matter. However, in the midst of this early cosmic landscape, 3 gigantic structures were discovered, so massive and bright that they instantly became one of the most mysterious mysteries of modern cosmology.
These objects received the unofficial name 3 Red Monsters. 3 Red Monsters. This very name reflects their nature. They appear unusually red due to their enormous distance and colossal redshift. Their light is stretched by the expansion of space so much that it comes from an era when the age of the universe was only a small fraction of its current age. But it was not the color of these objects that turned out to be truly surprising, but their incredible mass. According to traditional models of galaxy formation, such large systems should not have existed so early. It takes time to create a huge number of stars. It is necessary to accumulate gas, start the processes of star formation, and survive many cycles of the evolution of matter. All this looks like a long cosmic story. However, the 3 red monsters seem to have missed a significant part of this path and appeared already formed when the universe was still very young.
The most striking thing is that each of these galaxies contains a mass of stars comparable to the largest modern galaxies. Their stellar populations turned out to be so huge that a fundamental question arose. How were such structures able to collect so much matter in such a short period of cosmic time? To understand the scale of the puzzle, it is necessary to go back to the first hundreds of millions of years after the Big Bang. During this period, space was filled mainly with hydrogen and helium. Dark matter formed the invisible framework of future structures. Gas gradually accumulated inside its gravitational nodes. From these condensations, the first stars were born, then star clusters, and later, the first galaxies.
According to calculations, early galaxies must have been relatively compact. Their masses gradually increased due to gas absorption and mergers with neighboring systems. Growth has been happening step by step over billions of years. But 3 red monsters looks like this process has been accelerated to incredible proportions. Inside these objects, extremely intense star formation was taking place. The gas was turning into stars at a rate that significantly exceeded most known galaxies. Huge clouds of matter continuously collapsed under the influence of gravity. New generations of massive stars appeared. Their radiation filled the surrounding space with energy, and subsequent supernova explosions enriched the interstellar medium with heavy elements.
But even such a violent star formation does not give a complete answer. To create such massive systems, it was necessary to have gigantic reserves of gas already at the earliest stages of the universe's existence. It seems that in some regions of space, matter was concentrated much faster than previously thought. One possible explanation has to do with the unusual behavior of dark matter in the early universe. Although it remains invisible, it is its gravity that determines the formation of the large-scale structure of the cosmos. If the distribution of dark matter in certain regions turned out to be denser than expected, this could lead to an accelerated accumulation of matter and the birth of giant galaxies much earlier than standard predictions.
However, even this hypothesis does not eliminate all contradictions.
The masses of the three red monsters are so large that some models still have serious difficulties trying to explain their origins. The more accurately the parameters of these objects are estimated, the stranger the situation becomes. An additional mystery is created by their brightness. An enormous amount of light indicates the presence of a colossal number of stars, or the existence of extremely active processes in the central regions of galaxies. It is possible that supermassive black holes already existed in their cores, absorbing matter at great speed. If this is the case, then another problem arises.
Supermassive black holes also take time to grow. To reach millions or billions of solar masses, they must absorb the surrounding gas over a long period. But the early universe provided too little time for such rapid development. Therefore, the appearance of giant black holes in such young galaxies turns into a separate cosmological puzzle. Some scenarios suggest the existence of massive primordial black hole embryos. Instead of gradually growing out of the remnants of ordinary stars, such objects could have been born very large at once. If such a mechanism did exist, it could explain some of the observed features of three red monsters. But there is not enough evidence for this idea yet.
Even more intriguing is the question of the chemical composition of these galaxies. The young universe originally contained very few heavy elements. They appear inside stars and spread after they die. However, signs of complex chemical evolution in some early galaxies indicate that star formation processes may have begun much earlier than previously thought. If this is true, then the history of the first hundreds of millions of years of space turns out to be much more eventful. The formation of large structures could take place quickly and efficiently. It is possible that the early universe was a much more active environment than classical models showed. The peculiarity of three red monsters is also that they are not discovered alone. The very fact of the existence of several such objects at once hints that we may not be talking about a rare exception, but about a whole class of galaxies that previously remained hidden. If future observations reveal dozens or hundreds of similar systems, cosmology will have to seriously revise ideas about the first epochs of the universe. Each new assessment of the parameters of these objects raises additional questions. Perhaps their mass was overestimated. It is possible that some of the radiation is created by active nuclei, not stars. Perhaps the structure of galaxies differs from modern analogs so much that the usual methods of calculation give unexpected results. But so far, no explanation eliminates the mystery completely. The most radical hypotheses concern the fundamental properties of the early cosmos. If the three red monsters do indeed have the declared masses, it could mean that the processes of gas cooling, star formation, or the growth of dark matter structures occurred differently than current models suggest. In this case, these objects become not just unusual galaxies, but a kind of windows into the unknown physics of the early universe. The future of the galaxies themselves is also of great interest. Over billions of years, they had to continue to grow, survive numerous mergers, and evolve into gigantic modern systems. Perhaps some of the largest elliptical galaxies in today's cosmos are distant descendants of such objects. Their ancient light shows only the initial stage of history, while further evolution is hidden behind billions of years of cosmic time.
But even if the fate of these systems is only partially understood, their impact on our understanding of the universe has already been enormous. They make us take a fresh look at the first epochs of galaxy formation, the role of dark matter, the rate of star birth, and the growth mechanisms of supermassive black holes. Perhaps the most surprising discoveries are yet to come. If the three red monsters are indeed just the tip of a much larger phenomenon, then even more massive objects may be lurking beyond the already known regions of space. Even more ancient structures, even more incredible galaxies that arose almost immediately after the appearance of the first light sources in the universe.
It is this obscurity that makes three red monsters one of the most fascinating mysteries of modern cosmology. Their red glow comes from the depths of time, from an era when the cosmos was just beginning to take on familiar shapes. But instead of the expected picture of a young and slowly evolving world, these objects show something completely different. A universe capable of creating giants much earlier than seemed possible. And while the answers remain incomplete, the three ancient red monsters continue to keep the secret of their origins, like a message from the very beginning of cosmic history.
Over time, another mystery has formed around the three red monsters, related not only to their mass, but also to the very rate of accumulation of matter. In the early universe, gas was not evenly distributed. Huge streams of hydrogen moved along the giant cosmic filaments that form the large-scale structure of space. These streams gradually flowed into the region of increased density, where, under the influence of gravity, the birth of the first large objects began. However, in the case of three red monsters, it seems that such streams worked with extraordinary efficiency. It was as if colossal volumes of matter were sent into these systems almost continuously, maintaining rapid growth over millions of years.
Such processes must have been accompanied by an incredible release of energy. Each new star began to emit powerful streams of light and particles. A particularly important role was played by massive stars, which live for a relatively short time but have a huge impact on the environment. Their ultraviolet radiation heated the gas, creating shock waves and changing the structure of the interstellar medium. Usually, such activity gradually slows down further star formation, as some of the gas heats up and becomes less prone to gravitational contraction. But three red monsters apparently somehow overcame this limitation.
Perhaps the rate of influx of new matter was so great that even powerful feedback processes did not have time to stop the formation of new generations of stars. While some areas were warming up, others were already receiving fresh supplies of cold gas from the surrounding space. As a result, galaxies could maintain extreme growth rates for much longer than many existing models allow. The internal structure of these objects is of particular interest. The light that came from them after billions of years of cosmic time carries information only in a limited volume. Many details remain hidden. It is not known how complex their morphology was, whether they were already formed disk systems or gigantic chaotic clumps of matter experiencing continuous collisions and mergers. It is possible that there were dozens of regions of active star formation within them at the same time, each of which separately could compete with entire galaxies of later epochs.
It is possible that the three red monsters were located in special regions of space where the density of matter was significantly higher than average. Such regions can be considered as the embryos of future galaxy clusters. If this assumption is correct, then these objects could have become centers for the formation of gigantic structures that billions of years later turned into huge clusters of galaxies containing thousands of separate systems. The deeper this possibility is considered, the more interesting the picture of the early universe becomes. Instead of a relatively calm period of gradual growth, there was an image of the cosmos where individual regions developed at an astonishing rate. In such regions, star birth,
black hole formation and mass accumulation occurred almost simultaneously, creating objects that already in the first epochs of the universe's existence reached scales characteristic of a much later time.
But there is another problem. If such galaxies were indeed so massive, they must have had a tremendous gravitational influence. Their presence inevitably affected the surrounding space. They attracted neighboring clouds of gas, changed the trajectories of matter, and became centers of formation of new structures. Over time, entire systems of satellite galaxies could arise around them, gradually absorbed by a larger object. Each such absorption brought additional mass. Stars, gas, and dark matter poured into the central system, making it even larger. This process continues into the modern era in many giant galaxies. However, in 3 red monsters, such a mechanism had to work with incredible intensity already at the earliest stages of space history.
Particular attention is drawn to the possibility of the existence of extremely dense stellar regions within these galaxies. If a huge amount of matter was concentrated in relatively small volumes of space, the density of stars could reach exceptional values. In such conditions, interactions between objects occur much more often. Gravitational effects become more complex, and the evolution of the system accelerates. In the center of such regions, conditions favorable for the rapid growth of supermassive black holes could arise. Huge masses of gas continuously fell towards the central regions, forming red-hot accretion disks. The temperature of the substance rose to millions of degrees. The plasma streams emitted intense radiation capable of eclipsing the light of billions of stars. If such processes did indeed occur inside the 3 red monsters, then some of their extraordinary brightness may be due to the activity of giant black holes.
However, such a hypothesis raises new questions. Active nuclei usually have a powerful effect on the surrounding gas. Relativistic jets and high-energy particle flows can escape from the central regions. These processes can heat the interstellar medium and even stop further star formation. If there were such active nuclei inside 3 red monsters, why did galaxies continue to increase mass at such a rate? It is possible that the early universe provided conditions that were significantly different from those of today. Gas reserves were much richer. Space structures were in a phase of rapid growth. Even the most powerful energy processes could not be enough to stop the influx of new matter. At that time, galaxies and central black holes grew at the same time, feeding each other for a long time.
The more this scenario is considered, the clearer it becomes that 3 red monsters are at the intersection of several fundamental problems of cosmology. They touch on the origin of the first stars, the formation of galaxies, the nature of dark matter, the evolution of supermassive black holes, and even the structure of the early universe as a whole. Some calculations suggest that explaining such objects may require a revision of star formation efficiency. It is possible that the first galaxies turned gas into stars much faster than modern systems. If that's the case, then much of the early history of the cosmos looks very different. The first billions of years could have been an era of incredibly violent activity, during which the largest structures formed much more rapidly than previously thought.
But there is a more mysterious possibility. It is possible that 3 red monsters is evidence of processes that are still poorly understood. In the early universe, there may have been mechanisms of mass accumulation that were not accounted for in standard models. Perhaps certain properties of dark matter manifested themselves differently. It is possible that the conditions for the formation of the first stars were much more extreme. It is possible that some stages of cosmic evolution occurred faster,
under the influence of factors that remain unknown as yet. That is why these galaxies continue to attract attention. They don't just expand the catalog of distant objects, they question the usual ideas about how exactly the first giant structures of the cosmos arose.
Each new analysis of their properties does not reduce the number of questions, but on the contrary, makes the picture even more complex and mysterious. The light of 3 red monsters began its journey through space when many modern galaxies did not even exist. This light has survived the epochs of stellar generations, the emergence of new galactic systems, and billions of years of cosmic evolution. Today, it brings information from a time that is almost at the very origins of the observable history of the universe. And in this ancient light, there is a hint that the cosmos in its early youth may have been much more grandiose, active, and unpredictable than previously thought.
And the deeper the history of these objects is examined, the clearer one strange detail becomes. 3 red monsters didn't just appear early. They arose at a time when the universe itself was still in the process of fundamental transformations. Space still retained traces of an ancient era known as the Cosmic Dawn. At this time, the first generations of stars gradually changed the environment, saturating it with radiation and heavy elements. Many galaxies were just beginning their journey, but 3 red monsters has already shown signs of maturity that are hard to expect from such young systems.
One of the most unusual features is the estimated amount of stellar mass concentrated inside these objects. If the estimates are close to reality, then we are talking about the accumulation of a huge amount of matter in an incredibly short time. Such a result requires not just favorable conditions, but a whole chain of processes, each of which had to work almost without delays. The gas had to cool quickly, the gravitational structures had to grow rapidly, the formation of stars had to take place with exceptional efficiency. The slightest slowdown at any stage would significantly reduce the total mass of galaxies. Of particular interest is the question of what the first millions of years of the existence of these objects were like. Perhaps their origin began inside extremely dense regions of dark matter. Such regions could attract the surrounding gas much more efficiently than ordinary proto-galaxies. As a result, matter flowed to the center of future systems in continuous streams, forming giant reservoirs of cold hydrogen. It was this hydrogen that later became the building block for billions of stars.
In the early universe, cold gas represented the main resource for cosmic growth. As long as its reserves existed, galaxies could continue to increase mass. However, 3 red monsters apparently possessed almost inexhaustible sources of such a substance. Even intensive star formation did not have time to exhaust the incoming flows. This resembles the existence of peculiar cosmic nodes in which huge volumes of matter from the surrounding space converged. If such a picture is correct, then 3 red monsters may be associated with the densest sections of the ancient cosmic web. This gigantic network of filaments of dark matter and gas permeates the entire universe. Modern galaxies are located along these structures, but in early epochs, their role was even more important. They directed the movement of matter, determining the birthplaces of future giants.
The more matter accumulated inside galaxies, the stronger their gravitational influence became. Huge masses began to affect the surrounding space, changing the distribution of gas at distances of tens and hundreds of thousands of light years. Gradually, a complex system of interrelated processes emerged. Gravity attracted the new substance. New matter gave rise to stars. The stars changed the properties of the environment, and the altered environment influenced the further growth of the galaxy.
But it is here that one of the deepest mysteries appears. Under normal conditions, intensive star formation gradually begins to destroy its own basis. Young, massive stars emit powerful streams of radiation. Supernova explosions create shockwaves of colossal force. These processes scatter gas and reduce the efficiency of further formation of new stars. However, three red monsters somehow avoided rapid self-restraint.
Perhaps the scale of these objects was so large that even the most powerful flares could not seriously disrupt the overall flow of matter. While some areas were exposed to explosions and radiation, others continued to receive fresh gas supplies. In this case, the galaxy functioned as a gigantic, self-sustaining growth system encompassing vast volumes of space. Even more intriguing is the possibility that supermassive black holes, with masses of hundreds of millions or even billions of solar masses, already existed inside these objects. If this is indeed the case, then the question arises not only about the origin of the galaxies themselves, but also about the origin of the central objects in their cores.
The formation of such large black holes in a short time remains one of the biggest problems in modern astrophysics. Conventional scenarios assume gradual growth through gas accretion and merger, but it takes much longer to reach such a size than was available to the early universe. Therefore, some models allow for the existence of special mechanisms for the direct collapse of giant gas clouds. In this case, the black hole could have already appeared very massive almost from the moment of birth. If such a process really took place, then the central regions of the three red monsters could have been the places of origin of the first space giants. Huge black holes began to actively absorb the surrounding matter. The matter accelerated to enormous speeds inside the accretion disks. Temperatures reached extreme values. There was a powerful radiation that spread far beyond the boundaries of galaxies.
Some calculations show that such objects are capable of influencing not only their own galaxy, but also the surrounding intergalactic medium. Streams of energy can heat the gas at distances of hundreds of thousands of light years. They are able to change the rate of formation of new stars in neighboring systems. Thus, the three red monsters could not just be large galaxies, but important centers of evolution of entire regions of the early universe. At the same time, the question of their true number remains unresolved. Perhaps the discovered objects are only a small part of a much larger population of ancient giants. Limited observations mean that many such systems may remain invisible due to distance, orientation, or the presence of vast amounts of cosmic dust.
If in the future it turns out that the early universe was inhabited by many such objects, the consequences will be enormous. This would mean that the largest structures began to form almost immediately after the first stars appeared. Then the usual picture of the gradual growth of galaxies will require a serious revision. A special mystery is created by the red color of these objects. Of course, the main reason is due to the huge redshift. Space stretched for billions of years, lengthening waves of light. But some of the redness can also be explained by the intrinsic properties of galaxies. Huge clouds of dust are capable of absorbing short-wave radiation and altering the spectrum. This means that there could have been colossal reserves of interstellar dust inside the three red monsters already in the early history of the cosmos. And the presence of a large amount of dust in itself becomes a new mystery. Its formation requires generations of stars that must have time to synthesize heavy elements and eject them into the surrounding space. It turns out that by the time the light left these galaxies, a significant amount of stellar evolution had already taken place inside them. Once again, it seems as if the cosmic clock inside these systems was faster than in the rest of the young universe. The further the study of such objects develops, the more often the idea arises that the early universe may have been much more diverse than previously thought. It is possible that there were small, primitive galaxies nearby, and at the same time, gigantic structures already possessing enormous mass, complex internal organization, and active nuclei. This contrast makes the cosmic story even more amazing. And somewhere beyond the already studied regions of space, objects even older and more massive may be hidden. Perhaps there are galaxies whose light began its journey even closer to the moment of the birth of the first stars. Perhaps among them are structures that can cast doubt not only on individual details of current models, but also on the very notion of how the universe transitioned from primordial chaos to the gigantic cosmic architecture we see today. Perhaps the main value of three red monsters is not their size or their age. Their true significance lies in the fact that they show how incomplete our understanding of the first epochs of the cosmos remains. These galaxies seem to have stored information about time that has long since disappeared, about the time when space was just beginning to be filled with light, and the future structure of the universe was only formed from the flows of matter and dark matter. Every photon that came from these objects left them billions of years ago. During this time, the galaxies themselves must have changed beyond recognition. Their stars continued to evolve. The central black holes increased their mass. New mergers took place. New generations of stars were born. Shape and structure changed. The appearance that is visible today is only a moment from their distant past, a short fragment of history preserved in the ancient world. And yet, it was this fragment that turned out to be enough to raise many questions. Why did such massive systems appear so early? Where did the gigantic reserves of matter come from? How could such huge stellar populations form in such a short time? What role did dark matter play? How fast did the first supermassive black holes grow? And how many more similar objects lurk beyond the already discovered part of the early universe? The answers to these questions could change the way we think about the first billion years of cosmic history. It may turn out that the young universe was much more active and complex. Perhaps the largest structures began to form almost immediately after the appearance of the first light sources. Perhaps some processes of the early cosmos proceeded completely differently than is commonly believed today. But for now, three red monsters remains a mystery. They continue to exist somewhere in the depths of space and time, at a colossal distance from modern galaxies. Their ancient light still traverses space, carrying information from an era that is almost at the very edge of the known history of the universe. This light tells the story of giants that appeared too early, about structures that should not have had time to grow to such sizes, about galaxies that violate habitual expectations and force us to take a fresh look at the origin of cosmic scales. Perhaps in many years it will become clear how these ancient monsters appeared. It is possible that even more massive and even earlier objects will be found. Perhaps three red monsters will be only the first representatives of a huge family of galaxies, the existence of which is just beginning to be revealed.
But today, They remain some of the most mysterious objects of the early universe. 3 distant red lights continue to flicker through billions of light years. They appeared in an era when the cosmos was young, survived almost the entire history of the expanding universe, and brought to the present day evidence that the greatest mysteries may lie not in the future, but in the very beginning of the existence of space, time, stars, and galaxies. And while these ancient signals continue to come from deep space, the story of 3 red monsters remains open, not as a complete chapter of the cosmic annals, but as one of the most puzzling questions about how amazing the young universe really was.